Welcome to multi-AI agent architectures. Single agents struggle with complex tasks, but combining specialized agents unlocks advanced reasoning and parallel processing. Let's explore the core patterns. The sequential chain flows linearly. Agent A completes a task, passing its structured output as context to Agent B. This deterministic pipeline is ideal for predictable workflows. The router architecture handles varied requests. A lightweight router agent analyzes semantic intent using zero-shot classification, dynamically routing the payload to the most appropriate specialized agent. These specialized agents, like a code generator or data analyst, execute the task. With highly tuned prompts and specific tool access, they ensure domain-specific accuracy. For multifaceted problems, the hierarchical pattern deploys a manager agent. It receives a massive objective, decomposes it into a graph of subtasks, and delegates them to specialized workers. Worker agents execute subtasks in parallel, performing web searches or querying databases. They return findings to the manager, who synthesizes the disparate data into a cohesive output. In the collaborative Blackboard architecture, agents operate asynchronously around a shared memory space. This Blackboard acts as a persistent state manager and global context repository. Agents continuously monitor the Blackboard. When detecting relevant data, they pull the context, process it, and write results back. This mimics human brainstorming for open-ended research. The evaluator optimizer loop enforces quality control. A generator drafts a solution, and an evaluator critiques it against strict rubrics, iterating until quality thresholds are met. By leveraging these distinct architectures, engineers can design highly scalable, resilient, and intelligent AI ecosystems tailored to complex enterprise workloads.